Languages are divided into two types: statically typed languages and dynamically typed languages. Or in short, we can say static languages or dynamic languages. Examples of static languages are C# and Java. Dynamic languages are like Ruby, JavaScript, Python, and so on. But what's the difference? The difference is in static languages, resolution of types, members, properties, methods is done at compile time. So if we try to access a method that is not defined in an object, when we compile the application, we are getting an immediate feedback that's telling us that method or property is not found on that object. With dynamic languages, the resolution of types, properties, members, methods is done at runtime. But what's the benefit of that? First, I'm not an expert in programming languages, but based on my understanding, dynamic languages are a little bit easier and faster to write code with. But on the flip side, because we lose compile time checking, we have to write more unit tests to make sure the application behaves properly at runtime. Now, C# started as a static language, but in .NET Framework version 4, they added dynamic capability to it. And the intention was to improve interoperability with COM or dynamic languages in .NET like Iron, Python. If you're writing code for Microsoft Office applications such as Word or Excel, dynamic is a feature that is going to help you a lot. Without dynamics, you have to use reflection. What is reflection? Reflection is a way to inspect the metadata about a type and access properties and methods. Let me show you an example. Let's say I have an object here, give it a name of object and assign it to a string, my name. I can call the getHashCode method here like this, and that's pretty easy. But with reflection, if I want to call that method, my code will end up looking like this. First, I get the type of that object, and then I get a reference to a method called getHashCode, and that returns a method info object. Oops. Now I can invoke method info like this and pass some weird arguments here. As you see, this code is not very beautiful. So reflection is a little bit difficult and messy. The benefit of dynamic is that, let's say you're getting an Excel object and you know that that object should have some method called, I don't know, let's define an object here, Excel object. I set it to a string for now just for simplicity because I really don't have Excel objects here. But let's say, at runtime that object should have a method called optimize, for example. You see that we get compile time error because the object class here does not have a method called optimized. With dynamic, we can easily resolve this problem without having to use reflection. With reflection, our code would end up like this, whereas with dynamic, it looks like this. It's much cleaner. So that's how you use dynamics in C#. But how does all that magic happen, as in resolving types, properties, members at runtime? You should be familiar with CLR, or Common Language Runtime. It's .NET's virtual machine that gets your compiled code, which is in intermediate language, which is IL, then converts that or recompiles that into machine code at runtime. In .NET Framework version 4, they added a new component called DLR, which is Dynamic Language Runtime. So DLR sits on top of CLR and gives dynamic language capabilities to C#. Now, most often you're not going to work with that. It's just there. I'm just telling you that this is how the magic happens. Now, let's take a look at a few other things about dynamics. I can define a dynamic type here, give it a name here, and assign it to my name. And then in the next line, I can assign an integer to it. And that's perfectly fine. With static types like object, int, string, or whatever, this is not possible. We're going to get an exception. But if I run this code, the application runs successfully. There are no exceptions. Let's inspect this. I put a breakpoint here with F9, run the application in debug mode with F5, continue execution with F10. Let's put a watch on the name variable. Take a look here. So name is a dynamic and its runtime type is a string. But if I continue execution with F10, now its runtime type changes to integer. And that's one of the key differences between dynamic types and static types. With dynamic types, we can do whatever we want with them. And I think that's what makes them powerful in terms of writing code faster and easier. Now let me show you another example here. If I remove this line and instead try to apply a plus plus operator to this name variable, let's see what happens. This time we got an exception. Unhandled exception is of type runtime binder exception, which is a popular exception when working with dynamic types. And the exception message says operator plus plus cannot be applied to operand of type string. So at runtime, let me cancel that. So at runtime, the type of this name variable would be string. And of course, we cannot do that with a string. And that's the reason I told you with dynamic types, we need to write more unit tests to make sure application behaves properly at runtime. Let's take a look at another example. I'm defining a dynamic called A, set it to 10, then B set to 10, or let's say 5. This time I'm going to define a variable with var. Now var is not dynamic. Var is basically a shorthand way of writing code and letting the compiler decide what type a given variable should be. So if I say var c equals string, empty string, then if I hover my mouse over var, then var is a string. It's a short way of writing code. I could just write string here, but var is a little bit shorter. Now, the interesting thing here is if I define C as A plus B, because A and B are dynamic, C will end up being dynamic. Look, that's dynamic. Let's put a breakpoint here. Run the application in debug mode. I'm gonna delete this watch here and put A, B, C here. So continue execution with F10. So A is dynamic and its runtime type is integer. So is B. And so is C. So when you use dynamic variables in an expression, the expression will end up being dynamic as well. One more thing you need to know about dynamics is conversions or casts. Most often with dynamics, you get implicit conversion from and to the target type. So let me show you an example here. So I define an integer called I and set it to 5. Now I can define a dynamic called D and set it to I. In this case, I didn't have to specify a typecast or a conversion. At runtime, D will end up being an integer. Let's verify that. So continue execution with F10. We put D here in the watch window. So D is a dynamic and its runtime type is integer. Similarly, we can put dynamic on the right side of the assignment operator without the need to do any explicit casting. So if I define a long L here, I can put D inside long. At runtime, D will be an integer, and of course we can put an integer in a long variable without explicit casting. So the lesson is, when converting from dynamic to static types, if the runtime type of the dynamic object is implicitly convertible to the target type, you don't need to cast it. So let's verify this. So F10, F10, and I put a L here, and L, as you see, is long and its value is 5. And D is of course dynamic and its runtime type is integer. Well, that's it for this video. I hope you enjoyed it and thank you for watching.